This is the overall hardware setup for the project titled Bidirectional Grid Connected Inverter for a Battery Energy Storage System. In this project, we'll have two sources and two converters which will be connected using multiple winding transformer, and when the source 1 is present, the source 2 will get charged, and when source 2 is present, source 1 will get charged. These are the basic hardware blocks involved. The first block is the microcontroller block. This block is the gate driver block. This is also the gate driver block. This is the first source and the first converter block. This is the first source and the first converter block. This is the second source and the second converter block. The converter 1 and converter 2 would be connected using a multi-winding transformer. This is a voltage doubler circuit for boosting the output. This is the inverter wherein we have used 4 switches, and this is the resistive load across which will verify the inverter output. Now the operation. In the first phase, we'll give an input from the battery. The input to the circuit is a 12 volt battery. 12 volt 1.3 amps is the rating. The input from the battery would go as first source and to the first converter. At this time, the second source would get charged. We will connect the wires from the second source to the probes of the multimeter to show that the second source is getting charged. And during the second phase, the connection from the converter 1 would be disconnected. Source 1 would be disconnected, and will connect the battery to source 2. At that time, the source 1 will get charged. That can be seen using the multimeter. At the same time, using the voltage doubler circuit, the output would be boosted and given to the inverter circuit, wherein we can verify the inverter output using the resistive load. The input of 12 volts would be boosted to around 80 to 90 volts using the voltage doubler circuit. Now we'll switch on the circuit and see how it operates. We have switched on the circuit. In the first mode, the battery input would be given to the source 1. The source 1 would give the input of 12 volts and it will go to the converter 1. At this time, the source 2 would get charged. The connection from the source 1 is connected to the battery. The connection from the source 2 is connected to the probes of the multimeter to show that it is getting charged. So when the source 1 is present, source 2 will get charged, and we have connected the probes of the DSO across the resistive load which shows the output of the inverter. This is the inverter output. Each box is 5 volts, so around 8 volts is shown here, 8 to 9 volts is shown here. The probe is in 10x channel, so 10 into 9 is 90 volts. So the input of 12 volts is boosted and given as 90 volts. And battery is charged with 12 volts. This is the first direction, first mode, when source 1 is available and source 2 is getting charged. Now we'll see the second phase. Now in the mode 2, the source 1 is getting charged and we are giving an input to source 1 from the battery. So the source 1 is connected to the source 2 is connected to the battery, and source 1 is connected to the probes of the multimeter to show that the source 2 is charging. So in the first mode, the source 1 was giving input and source 2 was getting charged. The second phase, the source 2 will get the input from the battery and source 1 will get charged. So this is this mode 2 wherein the battery is connected to the converter source 2, converter 2, and the source 2 and source 1 and converter 1 is getting charged of 12 volts. We've connected the probes of the DSO across the resistive load which shows the output of the inverter. Again we can see the output to be around 8 to 9 volts and the probe is in 10x, so 10 into 9 is 90 volts. This is bidirectional grid connected inverter for a battery energy storage system.